Hello all, this is Kyle, and for our second Java tutorial today we'll be doing the factory pattern. Last time we did the event paradigm, and today we'll be doing another very useful pattern. It is very commonly used. In fact, if you go through the Java docs for the standard edition of Java, you will find that the factory pattern is quite commonly used indeed. So, what is the factory pattern all about? The factory pattern is a way which is a tool we can use to solve quite a recurring problem that comes up, especially when we start developing very large systems. And that is, we need to solve the problem of creating the correct instances of objects. What do I mean by this? Sometimes our problem concerns directly the creation of objects, and the factory pattern gives us a common way of going around solving that. So you shouldn't use the factory pattern anytime you want to create an object, but you should use the factory pattern when your problem is creating the correct object. And you will see this in the example I have soon. And we need two things for the factory pattern. Just like last time, we had this list, standard list of things we need, and for the factory pattern we have two things. So if we go to the list here, we see that we need the product. The product is the object which the factory will create. As you can see it here, the product is an interface or class that models whatever the factory will create. So say, let's take an example from the standard edition of Java. One of the classes is the document builder, and the document builder is the factory, and the product is the document. So that is an example of a product, and likewise the document builder is the example of a factory, which is the second thing we need here. The factory object is responsible for creating products given a situation. This is the important part of a factory, that a factory doesn't just pump out objects one after the other, but given a situation, given a set of arguments, it will give you back the correct product. And you will see what I mean by this, because the product is usually just one superclass. When I say the correct product, it means giving back the correct subclass of that superclass. And the factory object here is a behavior. Its behavior is usually defined by an interface, and this is something stylistic. I mean, you can define a factory even without using any abstract classes, without using an interface. Just write a factory class. In this example, we'll be using an interface though, so keep that in mind. Our problem today, our example problem today, is as silly as last time, but it's still I hope it serves its purpose well. And the problem consists of a person who wants to go traveling around a couple of cities, and each of these cities is connected to another city either by air, sea, or by a road. Now the problem is that the person needs a vehicle to travel from one city to the other, and depending on how the cities are connected to each other, the person needs to create needs to get the right vehicle. It is important to remember though that if possible, the person prefers going by sea first, if possible, otherwise by air, and the last resort he prefers to go by road. And that is our problem. So as you can see already, our problem is concerns creating the correct instance of a vehicle. So this is an ideal example of using a factory class. Let's start immediately then, and the first thing we need to do is create a city. So let's go and immediately create the city class. Now the city, as you will see, has nothing to do with the factory pattern. The city has to do with the fact that in our problem we mentioned that there are interconnected cities. So as I said in the problem statement, my city will be connected to others, and either by road, sea or air. And the way I'm going to store this in memory is by using this auxiliary class here called connection. Now once again, this is something stylistic. You can do it any way you like. The very hardcore programmers would probably use bits and play around with each individual bit. Any way that works is fine. And this connection class keeps 3 Boolean variables, and whether if road, sea or air is true, then if road is true, then the city is connected by road. Now notice the static modifier here. Why do I place static here? It is because from within the connection class I do not refer to anything in the city class. That means it's very much a utility class for city. In fact I could have placed this in its own file, but since no one else really needs to use this class, then I've placed it here and I've marked it as private, which means that the city class only can use it, and static, which means that the connection class is not bound to any instances of city. Now we will keep the connections in a hash map. This means that if the target city is the key, and the connection here is this class up here. So since we're using a hash map, it's very quick to find the correct city. Remember that generating a hash key is a constant time operation. We create a hash map in the constructor, and our cities will also have a name passed in by the constructor there. That's the get name. Now here are the 4 cool methods we have for the city. The first one is the connect with method. What this does is, for the city given another destination city, you can tell it by which transportation methods it is connected. So what we do is add the city as a key into this hash map. Like this. And then we need to create an instance of connection here and pass in these 3 parameters here. So now if I want to check whether, which we'll do just after this, if I want to check whether city B is connected by road, I place B here, I search for the key B here, and then check it using the connection class as the value. And in fact, here are the three methods which ask this city whether I can reach another city by road, for example, this one. Now you can write a lot of if statements into each other here, but we can do it quickly like this. See this, I give it and, so let's explain what happens here. The destination, as I said, I can use it as a key for this hash map to wait a second, to look up whether it's connected, and if it isn't, it won't even be in here. So the first thing we check is whether the destination is in this hash map. Now if that is true, then we need to check whether it is connected by road. So we use the city, the destination, as the key once again for the hash map, which gives us back an instance of connection, and then we check the road variable there. See? Now the more observant of you would tell me, but this could return null since it's all in one statement. But remember that the Boolean AND operator first executes this part. If this is immediately false, then it will skip this and immediately return false here. So this protects us from getting a null exception here. Let's add the two other methods for C and the air.